So let's go ahead and talk about some double and half angle identities today. So double angle identities are when you have the measure of the angle doubled. Now, this does not always mean that you land on the unit circle. Of course, we do have some multiples that this happens, like 30 doubled is 60 and 60 doubled is 120. And all three of those are on the unit circle, but we do have instances where it goes beyond the unit circle, or we have times that it just doesn't. So we can use these double angle identities to still find that measure because we can still double the angle and base it on something that is on the unit circle. And so, as you know, those trig ratios do not just double because the angle is doubled. So, for example, if we have the sine of 30 degrees, that is 1/2, but the sine of 60 degrees is the square root of 3 over 2, which is definitely not 1/2 times 2. So we can't just take that value and multiply it. So these identities help us find that value even when it doesn't fall on the unit circle. So let's go ahead and look at finding some values for when we don't know theta, but we still need to find it. So if cosine of theta is 8 over 17 and 3 pi over 2 is less than theta, which is less than pi over 2, which this statement tells you what quadrant you are in. Because if you think about where we are on the unit circle, over here, the positive x-axis is 0 and 2 pi. You've got pi over 2 for the positive y-axis. You have pi for the negative x-axis, and then your negative y-axis is 3 pi over 2. So if we're between 3 pi over 2 and 2 pi, that means that we are in quadrant 4. And so that is going to matter because that tells us what sign the function that we're using should have when we plug in for theta. So we're finding the sine of 2 theta, and we know that we're in quadrant 4, and that cosine here is positive. And so what we're going to do is we're actually going to use the Pythagorean theorem because we actually need the sine of theta in order to use this identity. So we know that cosine is adjacent, or x, over your hypotenuse, or r. So we are going to use 17 squared equals 8 squared plus x squared, because we are looking for y. So I'm going to use y squared. And so that gives me 289 equals 64 plus y squared. And so when I subtract 64, I get 225, and that equals y squared. So y is 15. So I know that sine theta is going to be equal to 15 over 17. So then I am going to take these two trig values and I'm going to plug them in to my function. So I'm going to use that identity of sine 2 theta equals 2 times sine theta times cosine theta. And so the sine of 2 theta is going to equal 2 times our sine, which is 15 over 17, times cosine, which is 8 over 17, and sine 2 theta, we're going to multiply across, And so that is going to give us 2 times 15 times 8. And that is going to be 240 over 289. Now, since we are in quadrant 4, there's one thing that when I made that sign value, I did not do. Sign is negative here since we are in quadrant 4. And so then actually when we multiplied this, we should have had a negative 15, which gave us a negative 240 over 289. Now, a lot of people will just do the basic math with this and then put the appropriate sign when they get their final answer. That is also acceptable. That's actually the way that I was taught to do this. And so that's why sometimes I go back and I just add the signs later. So this is our final answer though. And of course, this will not simplify, and it is definitely a weird decimal that is not going to fall in your unit circle. So now we are given that the sine of theta is a negative 1/3, and we are between pi and 3 pi over 2. So this means quadrant 3. So we are going to be in quadrant 3, and we are going to be finding the tangent of 2 theta. So our tangent identity is a little bit funky looking because it is the tangent of 2 theta equals 2 tan theta over 1 minus tangent squared theta. So to find this, we only have sine. So what we are going to have to do is we are going to have to find that third side of the triangle to make our tangent ratio. So our sine is y over r. So in Pythagorean theorem, we have 3 squared equals negative 1 squared plus x squared, because that's what we are looking for. So that's going to give us 9 equals 1 plus x squared. So we are going to have to subtract the 1, which gives us 8. So 8 equals x squared. And so then when we take the square root, we're going to get 2 square roots of 2 equals x. So our tangent ratio is going to be y, which is 1 over 2 square roots of 2. And of course, we're going to have to rationalize this. So square root of 2 over square root of 2, that is the square root of 2 over 4. So our tangent is the square root of 2 over 4. So, and I'm just going to go ahead and leave it positive since we are in quadrant 3. And we are going to then plug it into our identity. So the tangent of 2 theta is going to equal 2 times the square root of 2 over 4. And then 1 minus the square root of 2 over 4 squared. So we have the tangent of 2 theta equals, and when we multiply by 2, we have the square root of 2 over 2. And then we're going to go ahead and square our square root of 2 over 4. And so that is going to give us, I'm going to go ahead and change the 1 to 4 over 4 as well. Actually, wait, I'm not going to, because when we square that, we are going to get 2 over 16. And then we have the tangent of 2 theta equals the square root of 2 over 2 all over 16 over 16 minus 2 over 16. Yes, I know that will reduce. Honestly, it'll all come out in the end. If you want to go ahead and reduce it, you can. So then we are going to go ahead and subtract. And yes, I do. I should have changed color a long time ago. So we're going to have the tangent of 2 theta equals square root of 2 over 2 over, see, this is going to be 14 over 16. Yes, that will still reduce. We are now need to flip and multiply. So we're going to have the tangent of 2 theta equals the square root of 2 over 2 times 16 over 14. And we can cross reduce. So we've got 1 and 8. And that's going to give us 8 square roots of 2 over 14. We can still reduce that. And so we are going to. So we have the tangent of 2 theta equals 4 square roots of 2 over 7. And so that is our final answer. Okay, so for number 3 here, we have been given that tangent of theta is the negative square root of 7 over 5, and we are between pi over 2 and pi. So this means that we are in quadrant 2, and we need to find the cosine of 2 theta. Now let's go ahead and look at our identities for cosine 2 theta. We actually have 3, and all 3 will give you the same value. The hardest part is picking which one to do. So I am given tangent. No matter what, I'm going to have to find my hypotenuse because I am going to have to use a function with my hypotenuse because all of these involve sine and cosine. So I'm actually going to use this bottom one, that 2 cosine squared theta minus 1. And one of the reasons why I am doing that is because I'm already having to deal with a negative, and that negative is going to have to be in my answer. A lot of people don't want to deal with the negative, and so they will go ahead and find sine as well. I can go ahead and show you how to find it with both. So you should wind up with the same answer no matter what. So we are definitely going to have to find that hypotenuse. So we are given tangent theta. We are in quadrant 2. So we actually should have a negative x value. So remember, tangent is y over x. So we're looking for r. So r squared equals square root of 7 squared plus 5 squared. So r squared equals, actually 7. I don't know why I started to say 49. Plus 25. And so that gives us 34. And so r equals the square root of 34. And, not 34, 32. What am I thinking? And so that simplified is going to be 4 square roots of 2. So now we are going to go ahead and I'm going to do cosine first. And so I'm going to make that ratio. So cosine theta is going to be negative 5 over 4 square roots of 2. Now, I'm not really going to worry about rationalizing. I can. In fact, yeah, I probably just should. So you can plug this in unrationalized because you are just going to square it and you're going to undo all of that work anyway. You know what? I'm just going to show you guys what's going to happen there. So we're going to go ahead and plug this in unrationalized. So that identity that we're using is cosine 2 theta equals 2 cosine squared theta minus 1. And so that cosine's going to get plugged in. So we have 2 and then negative 5 over 4 square roots of 2 minus 1. And so when we multiply here, we are going to have, and that's going to be squared. So we're going to square this, and it's going to be 2 times 25 over 32, because that 4 squared is going to give us 16. The square root of 2 squared is going to be 2. So this is going to be 32. And then we're going to subtract the 1. And so now we have 50 over 32 when we multiply minus 1. And so this is going to give us, we're just going to go ahead and change that 1 to 32 over 32. And so that gives us 18 over 32, which is 9 over 16. So this is our cosine 2 theta. Now we also have that other identity, which uses sine. So that's the one that I would use. So we've got 1 minus 2 sine theta. And so I'm going to go ahead and show you how to use that one really quick as well. So, our sine theta, that is going to be, that's going to be the square root of 7 over 4 square roots of 2. And so this case, it will be positive. And so that identity for cosine 2 theta equals 1 minus 2 sine squared theta. So we're going to go ahead and put in that sine. So we've got 2 times square root of 7 over 4 square roots of 2 squared. And so we've got 1 minus 2 times 7 over 32. And so 2 times 7 is 14 over 32. And so we have 32 over 32 minus 14 over 32. So 32 minus 14 is 18 over 32. And so this is going to reduce to 9 over 16. So do you see how we got the same value? So in this case, yeah, I got the same value, different identities. They just both did cosine 2 theta. So always look and just see what you can find. Sometimes it's what are you more comfortable with using. So it doesn't matter which one you use. They will all 3 of those spit out the same value, but I am not working at a third time because we are already quite long today. All right, so for half angle identities, we have, this is when you need half of an angle that is, or a weird angle that double that angle might be on your unit circle. Or you just our given values, kind of like we did with the double angle. So we do have only one identity for both sine and cosine. Yes, I know you see those positive and negative. So pay attention to quadrant. And it'll tell you which one you need. And then, of course, tangent does have 3. Now, I will tell you, I usually look and see which one of these last two that are possible, because sometimes it's just not that easy to get that square root in there and deal with. I don't want to deal with that unless I have to. So let's go ahead and find the exact value of each expression here so we can figure out how to use these half angle identity. So first we need the cosine of 67.5. So I'm going to express 67.5 as a fraction, and notice it's 0.5. So 67.5 is equal to the cosine of 135 over 2. And if you put that in your calculator and use math and frac, that is what it is going to give you, is 135 over 2. So 135 is on the unit circle. So we have values that we can use for it. So what we are going to do is we are going to use that cosine identity. So we're going to have the cosine of theta over 2 is plus or minus, and we have 1 minus cosine theta over 2. And we're going to go ahead and plug in what we know. So we have the cosine, and we're going to use 135 because we always use that number. And then we're going to have plus or minus, and we have 1 minus the cosine of 135 because that was our theta. So we're always using the numerator. And then that's over 2. So now we are going to have, let's see, the cosine of 135 over 2 is equal to plus or minus. And then we know that the cosine of 135 degrees is the negative square root of 2 over 2. I think I totally miswrote that. Because that should be plus. And then we have that negative square root of 2 over 2. I think I was thinking about that becoming negative. So now we have the cosine of 135 over 2. And so this is plus or minus, and we are going to now go ahead and try to get equivalent fractions. So we've got 2 over 2, and we're minus the square root of 2 over 2, and then that's over 2. So we are going to have our cosine. Gosh, that is really big. Of 135 over 2, and that is going to equal plus or minus, and I'm going to put all of this together in one fraction underneath the radical. So we're going to have 2 minus the square root of 2 all over 2, and then that's divided by 2. So we are going to then flip and multiply inside the radical. Now I will tell you, we will not get rid of the radical completely with this. But we will have our cosine of 135 over 2 equals plus or minus, and we have 2, actually I need to write this a little bit smaller so we don't get into the other. So this is going to be 2 minus the square root of 2 over 2, and then times 1 over 2. So we have the cosine of 135 over 2 equals plus or minus. And so this is going to give us 2 minus the square root of 2 over 4. And so we can go ahead and get rid of at least the radical in the denominator, because technically right now this is a square root over a square root. So we can't have that square root of 4 in our final answer because that's in the denominator. That's not okay. So we're going to have the cosine of 135 over 2 equals plus or minus the square root of 2 minus the square root of 2. Yes, I know we have a root and a root. It's okay. So we can't go any further with that, and we're not going to. So this is actually our final answer except for quadrant. So our 67.5 is in quadrant 1. And so cosine is positive in quadrant 1. So for our final answer here, we are going to have the square root of 2 minus the square root of 2 over 2. And this is our final answer. So we are positive since we are in quadrant 1. All right, so then for our tangent, we have the 157.5, and we are going to go ahead and make that the equivalent fraction. So we will have the tangent of 315 over 2. Okay, so we are using that 315 in our identity. And so for this one, I am not going to use the identity that has the square root because I don't have to. And so I am going to use the tangent of 315. Actually, I'm just going to write that identity first. I'm going to use, let's see, my sine theta over 1 plus cosine theta. And so you have the tangent of 315 over 2. So the sine of 315 over 1 plus the cosine of 315. So we have the tangent of 315 over 2 equals our sine of 315. So on the unit circle, that is the negative square root of 2 over 2 over, see, our 1, I'm going to go ahead and just turn that into 2 over 2 because everything has a denominator of 2 plus the square root of 2 over 2. And so we have the tangent of 315 over 2. And so we're going to make this bottom part of our complex fraction. We are going to make that one big fraction. So we have 2 plus the square root of 2 over 2. And so now we are going to need to flip and multiply. So we have the tangent of 315 over 2 equals the negative square root of 2 over 2 times 2 over 2 plus the square root of 2. So we have the square root of 2 over 2 plus the square root of 2. So we can't leave that radical in the denominator. So we are going to multiply by the conjugate of 2 minus the square root of 2. And so that is going to leave us with, we're going to have to come back up here so we get more room. And that is going to give us, see, the tangent of 315 over 2 equals, so we're going to have to multiply on top. So that's going to give us a negative 2 square roots of 2 plus 2 over 2. So we actually can reduce all of this by 2. And so we have the negative square root of 2 plus 1. Or we can flip that around to 1 minus the square root of 2. Either answer is actually acceptable. All right, so let's go ahead and look at the sine of 11 pi over 12. So this is in radians. And so what we're going to do for this is, first of all, we are going to look at what quadrant are we in, because I only have a radical that I can use for this identity, because we have that sine of theta over 2 equals plus or minus 1 minus cosine theta over 2. So we are looking at using the sine of 11 pi over 6 divided by 2. And so what I did here was I actually cut that denominator in half, because remember, that makes your pieces twice as big. So it gives you double the quantity. So we are going to go ahead and use our 11 pi over 6. So let's go ahead and get that plugged. So we have the sine of 11 pi over 6, then divided by 2. And that is going to be plus or minus the square root of 1 minus, and then our cosine for 11 pi over 6 is the square root of 3 over 2. And that is over 2. So to simplify, we are going to go ahead and make this a fraction. So we have 2 over 2 minus the square root of 3 over 2, and then we're divided by 2. So after this, we are going to have plus or minus, we've got 2 minus the square root of 3 over 2. That's all divided by 2. And then we are going to flip and multiply. So we've got 2 minus the square root of 3 over 2 times 1 over 2. So we have plus or minus, and we have 2 minus the square root of 3 over 2. And actually that's going to be over 4 because we're going to multiply those together. Now technically we can't have that radical in the denominator that we currently have. So this is going to be the square root of 2 minus the square root of 3 on top over 2, because the square root of 4 is 2. And then we are going to have to pick a sign. So 11 pi over 12 is in quadrant 2. So sign is positive in quadrant 2. So we are going to have the sign of 11 pi over 12 is a positive square root of 2 minus the square root of 3 all over 2. Okay, so let's look at some more simplifying. So on number 7, we have if cosine is the negative 3 over 8 and theta is between pi over 2 and pi, we need to find the sine of theta over 2. So we are going to first figure out what quadrant that number 7 is in. So currently this would put us in quadrant 2, but just because we're in quadrant 2 doesn't mean that we can cut it in half and determine what quadrant we're in. So you always have to cut these values on the outside of the inequality in half as well. And so let's go ahead and look at where theta over 2 would be. So theta over 2 is going to be with pi, between pi over 2 and pi over 4. So that is going to put us in quadrant 1. So theta over 2 lives in quadrant 1. So now we're looking for the sine of theta. So we are going to use that identity of the sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. And so the sine of theta over 2 is going to equal, and since we're in quadrant 1, I'm not going to worry about the plus and minus because we should be positive. And we're going to have 1 minus our cosine, which is a negative 3 over 8 all over 2. And so we are going to have 8 over 8, since that denominator was 8, plus 3 over 8 over 2. And then we will add our fractions together. So we have 11 over 8, then over 2. And we have to flip and multiply. So 11 over 8 times 1 over 2. And then that is going to be 11 over 16 And so the sine of theta over 2 is going to equal the square root of 11 over 4. And then for number 8, we're going to do something very similar. So we have sine theta equals negative 12 over 13. And we know that theta is between 3 pi over 2 and pi over 2. So when we cut that in half, because this is currently quadrant 4, then 3 pi over 2, half of it is 3 pi over 4. And then theta over 2, and then just pi. So this does put us in quadrant 2. So for tangent, we're given sine, and so we have some options. So everything that doesn't require a radical requires both cosine and sine. So what we could do first is go ahead and find the missing piece of the ratio, because our 12 should be our y, our 13 should be our x. So, wait, this isn't tangent. This is y over r. So we should be able to find our x. So we should have, let's see, 13 squared equals 12 squared plus x squared. So we've got 169 equals 144 plus x squared. And so when we subtract, we get 25 equals x squared, and so 5 equals x. So our x equals 5. So we already have our sine, but then our cosine should be 11, what am I thinking? 5 over 13. So now we are going to go ahead and plug that into our identity. Now, really, there's not a better one of those last two for this problem. I'm going to go ahead and use the tangent of theta over 2 equals 1 minus cosine theta over sine theta. And so when I plug this in, I'm going to have the tangent of theta over 2 equals 1 minus cosine theta, so that's 5 over 13, over sine theta, which is negative 12 over 13. And then we will go ahead and make that 1 into 13 over 13. So we've got 13 over 13 minus 5 over 13 over negative 12 over 13. And so we will go ahead and add those, well, subtract technically. And so we have 8 over 13 over negative 12 over 13. And so flip and multiply, so 8 over 13 times 13 over negative 12. And cancel the 13s, that gives us 8 over negative 12. And then we have negative 2 over 3. And so that is our tangent of theta over 2 is negative 2 over 3. All right, so for number 9, I know this is starting to get to be a long video. So for number 9, we have the tangent of theta is 4 square roots of 3, and theta is between pi and 3 pi over 2. So right now, theta is in quadrant 3. So this is one I definitely wanted to look at because obviously the last two, we've kind of just been able to cut the quadrant in half and we know where we were. We don't have a quadrant 1.5. So what's going to happen here? So let's look. We've got pi. We're going to divide that by 2 because we're going to have theta over 2. And so this is going to become pi over 2. So this is the low end. And then we've got 3 pi over 2, which becomes 3 pi over 4. Both of these angles land in quadrant 2. So that is how cutting those angles in half definitely lets us know what's going to happen. So now we have that. We have the tangent of 4 square roots of 3. And we need the cosine of theta over 2. So we have, of course, only one identity that's going to work for that. And we're in quadrant 2, so we know that this one actually is going to be positive when we're done. So we do need to go ahead and use the Pythagorean theorem to find the rest of our ratio, because tangent is y over x. And so we've got 4 square roots of 3 over 1. So that's going to give us r squared equals 4 square roots of 3 squared plus 1 squared. And so we've got 16 times 3. When we square the 4 square roots of 3, that's 48 plus 1. So r squared equals 49. And so r equals 7. And so since our r is 7, our cosine for our identity is going to be 1 over 7. And technically, since we're in quadrant 2, that's negative. So we can go ahead and we need to go ahead and use it like that. So for our cosine of theta over 2, that identity is plus or minus the square root of 1 plus cosine theta over 2. And we have the cosine of theta over 2 equals, and see, actually, I'm just going to leave the minus because that's what we need to have. And we have 1 plus a negative 1 over 7 over 2. So then we have that cosine of theta over 2 equals a negative 1 minus 1 over 7 over 2. Cosine of theta over 2 equals a negative, and then we have 1 minus 1/7. So that is going to be 6 over 7 divided by 2. So we have the cosine of theta over 2 equals negative 6 over 7 times 1 over 2. And so then we have the cosine of theta over 2 equals negative and square root of 6 over 14. And we have cosine of theta over 2 equals negative, and we can go ahead and just simplify. So we got 3 over 7. So we're going to have to multiply by the square root of 7 over the square root of 7, because this is technically square root of 3 over square root of 7. And so our cosine of theta over 2 equals a negative square root of 21 over 7. And now we are to the last part of the lesson, which is solving equations. So we are still going to solve equations with these identities. And so we are given here some double angle identities in equations. And so we're going to substitute, simplify as much as we can. And so let's go ahead and look at what we've got. So we have the sign of 2u here, and that's a double angle identity. So that is going to be hard to solve for. So we are going to go ahead and use an identity and get that double angle out of there. So we are going to use 2 times sine u times cosine u plus 4 cosine u equals 3 cosine u. And we are going to go ahead and try to get everything on the same side. And so technically, this 3 cosine u and the 4 cosine u are like terms. So we have minus 3 cosine u. And this is 0. So we have 2 sine u cosine u and plus cosine u. And we're going to factor out that cosine because it appears in both. So we're going to have cosine u times 2 sine u plus 1 equals 0. So we have cosine u equals 0, and then 2 sine u plus 1 equals 0. And so we have for cosine u equals 0 between 0 and 2 pi, that is going to be that u equals pi over 2 and 3 pi over 2. And then for our other factor, we're going to subtract 1. So we have 2 sine u equals negative 1 divided by 2. Sine u equals negative 1/2. So u equals 7 pi over 6 and 11 pi over 6. So all 4 of these will be your final answer. So we have pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. All right, so one more time. So we have a cotangent of 2 theta in this next equation. So what we are going to do is we're going to use one of our tangents. Actually, wait, no, we only have one tangent for this. And so I'm going to come over to the side for a second. So side quest for something that is not rearranging a Pythagorean. So if the tangent of 2 theta is going to be 2 tangent theta over 1 minus tan squared theta, then cotangent 2 theta is going to be 1 minus tan squared theta over 2 tan theta. So we are actually going to use that because it's just the reciprocal. So we're going to have 1 minus tangent squared theta over 2 tangent theta times 2 tan theta plus 2 equals 0. And what luckily happens for us is that we can multiply and get rid of that fraction because the two tan thetas will cancel each other. So that gives us 1 minus tangent squared theta plus 2 equals 0. And then we have like terms that we can put together because 1 plus 2 is 3. So we have negative tangent squared theta plus 3 equals 0. And we have negative tan squared theta equals negative 3. And then tangent squared theta equals 3 when we divide by negative 1. And then we have to take that square root. And so we have tangent theta equals plus or minus the square root of 3. So we have to look in quadrants 2 and 3 for the values of tangent that satisfy this. And that is going to be theta equals 2 pi over 3 and then 4 pi over 3. All right, so now let's do this with some half angle identities. So only 2 more problems and then we are finally done. So for our half angle identities, one thing that we're going to do to kind of deal with the fact that we have to put in something with a square root is we're going to square the entire equation right off the bat. So this means that when we square that identity, so we are using the sine of theta over 2, that square root of 1 minus cosine theta over 2 is getting squared, and so the square undoes the radical. So we don't actually have to plug in that radical. So we have the cosine x plus 2 squared equals 1 minus cosine theta over 2. And then we just have to factor. So we're going to have, or not factor, multiply. So we are going to have cosine squared x plus 2 cosine x plus 2 cosine x plus 4 equals 1 minus cosine theta over 2. And so we're going to combine like terms. And so we have cosine squared x plus 4 cosine x plus 4 equals 1 minus cosine theta over 2. And then we are going to multiply both sides by 2. So we have 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine theta. Let's go ahead and get everything to one side. So we are going to subtract 1 and add cosine theta. That's going to give us 2 cosine squared x plus 9 cosine x and plus 7 equals 0. So we are going to kind of take another side quest for this for factoring. So we're going to take out our cosine and replace it with an x. That is going to give us 2x squared plus 9x plus 7. So we have x squared plus 9x plus 14. And so we have x plus 2 and x plus 7. And that gives us, let's see, oh, and we still need to divide by 2 because this is slide and divide. So we got to divide by the number we slid. So that gives us x plus 1 and then 2x plus 7 because that 7 doesn't divide completely. So we are left with cosine x plus 1 and 2 cosine x plus 7. So we have cosine x plus 1 equals 0. And I'm going to give a little bit more room there. That gives us cosine x equals -1. And so we have x equals pi for that one. And then we have 2 cosine x plus 7. So we're going to subtract the 7. And so 2 cosine x equals -7. So cosine x equals -7 over 2. So this is way out of range for cosine. So there is no solution for that factor. So our only solution for the entire equation is pi. All right, last question. We have number 13. And so this is another half angle identity. And so what I see is we've got a half angle identity that's already squared for cosine. So we don't have to worry about squaring the entire thing because that is already squared. So, and then for tangent, I am going to go ahead and use my 1 minus cosine over sine because I will have a cosine in the numerator with cosine's identity already. So that kind of just keeps things similar in the same places. So we will go ahead and keep the 1/2. And that is multiplied times tangent. And so my tangent of a over 2 is going to be 1 minus cosine a over sine a minus, and then cosine squared of a over 2. And that is going to be 1 plus cosine a over 2. And then I have cosecant a. I'm going to go ahead and use the reciprocal there. So I've got 1 over sine a, and that is actually going to give me a like denominator when I go and try to solve. So when I multiply, I've got 1 minus cosine a over 2 sine a minus 1 plus cosine a over 2 sine a equals 1. So since I have a like denominator, I can put these two fractions together. So we have 2 sine a on the bottom. And so then I have a 1 minus 1. So those cancel each other. And then I have a negative cosine a minus cosine a. So that becomes a negative 2 cosine a. And that's over sine a, and that equals 1. So these 2's will cancel. So I have a negative cosine a over sine a equals 1. Well, cosine over sine is cotangent. So I have a negative cotangent a equals 1. And of course, negative cotangent, we can divide that by a -1 or just multiply by -1. That's usually easier. And then that gives us cotangent a equals -1. So go ahead and use the reciprocal of that, and that is going to be tangent of A equals -1. So any place between pi and 2 pi, so we're looking in quadrants 3 and 4, that A or tangent is -1, and that gives us A equals 7 pi over 4.